So hi all, today we'll start with chapter 12 of class 10 science, the electricity. And we'll be discussing about the following topics. Introduction about the chapter, electric current, electric potential and potential difference, and electric circuit. Okay. So introduction. So this chapter is all about electricity. So as you are very familiar with the term electricity, it is a source of energy that has made our life comfortable and easy, right? And we depend on electricity for almost all activities in our day-to-day life. I have already given an introduction about this chapter and we have defined electric current also, but still we'll repeat once again. So basically, an electric charge is a fundamental particle in an atom. It can be positive or negative. You're familiar with this, right? Electric charge. It can be positive or negative. And what are the main properties of this electric charge? Like charges repel each other. That is, if two charges are positive or two charges are negative, they repel each other. Same way, if unlike charges, that is one charge is positive, another charge is negative, they attract each other. An electric charge is a very important term in this chapter of electricity. That is, electric charge is denoted by using symbol Q. Capital letter Q is used to denote electric charge. Its SI unit is coulomb. Okay, SI unit of electric charge is coulomb. So these two terms you need to remember. It is denoted by Q and its SI unit is coulomb. It is the name of a scientist, Andre Coulomb. And it is denoted by the SI unit is denoted by using letter capital C. So capital Q and capital C. Then charge on an electron is given by minus 1.6 into 10 raised to minus 19 coulomb. This much charge an electron possesses. This value also you need to remember. Now electric current. See, current is a common term, right? Water current, air current, like that we commonly use. The flow of water in rivers and canals is known as water current. Similarly, flow of charge in a conductor or metallic wire is known as electric current. So the simple way of defining or understanding electric current is, it is the flow of electric charge in a conductor. In a conductor, why there is a flow of electric charge in a conductor only, not in all materials? Because in a conductor there are free electrons. Free electrons means loosely bound electrons. They are free to move. So they can move from one part of the conductor to another part. But all materials are not conductors. You know that. What are examples for conductors? All metals are conductors. Whereas wood, plastic, paper, all these are not conductors. They do not conduct electricity. So definition of electric current is like this. Electric current is defined as the amount of charge flowing through a conductor in time t. Small letter t is used. It is denoted by using symbol I. Capital I is used to denote electric current. So electric current notation is capital letter I. The formula for electric current is current is equal to charge by time. Okay, charge by time. And for charge we denote using letter Q and time using letter T, small letter T. So we get the formula like this. I is equal to Q divided by T. So I is equal to Q divided by T. This is our formula for electric current. Okay, very important formula of this chapter. I is equal to Q by T. Now SI unit of electric current is ampere. Okay, this is also by the name of a scientist, physicist, Andre Ampere. So it is denoted by A. So each of these terms, formula, definition and notation, its SI unit, everything you need to remember. So now we have discussed electric charge and electric current, its notation as well as its SI unit. Now in detail about unit of electric current. we have the formula of electric current. I is equal to Q divided by T. Okay, this is our formula for electric current. So from this formula, we can write down the unit of electric current. What is unit of Q? Charge. That is coulomb. Similarly, SI unit of time is second. So we can write unit of current, that is ampere. 1 ampere is equal to coulomb divided by second. In units, everything I have written in units. Right? This formula I have used, and left hand side is current, and the unit of SI unit of current is ampere, that we have already seen. Then SI unit of charge is coulomb, that also we have written. And SI unit of time is second, that also we have written. So we get a formula in terms of their units as 1 ampere is equal to 1 coulomb divided by 1 second. That means using notation we can write it as 1 ampere, 1A is equal to 1 coulomb per 1 second, that is 1 coulomb per second, or 1 coulomb second to the power minus 1. So this is how we write 1 ampere as 1 ampere is equal to 1 coulomb per second. Now some other smaller units are also used. They are milliampere and microampere. This is read as milliampere. So milliampere means 10 raised to minus 3 ampere. So smaller values of current. If you want to represent small values of current, we use these units. Instead of ampere, we write milliampere. Similarly, 10 to the power minus 6 ampere is denoted by using microampere. 1 microampere is equal to 10 to the power minus 6 ampere. So remember these two also. Okay, milliampere is 10 raised to minus 3 ampere and microampere is 10 raised to minus 6 ampere. So these are the units of electric current. Now what would be the direction of electric current? That is also very important. Okay, direction of electric current is taken as opposite to the flow of electrons. We already defined electric current as flow of electrons, flow of charge carriers, that is nothing but electrons. But the direction is taken as opposite to the flow of electrons. The reason is electrons were not known at the time when the phenomenon of electricity was discovered. Even though the phenomenon electricity was discovered, that time electrons were not known. What are these charge carriers? So it is believed that the electricity is due to positively charged particle. Accordingly, the direction is also taken. Then later electrons were discovered, but still the direction is considered to be the direction of opposite to the flow of electrons. Okay, so this is how the current flow direction is. The current was considered to be flow of positive charge, like that it is considered. So always current flow direction is from positive to negative, positive to negative. Now we'll define 1 ampere. Always in physics, any term, whatever term we are, physical quantity we are studying, its equation you need to remember, its SI unit you need to remember, as well as definition of that unit also we need to remember, we need to understand. So how do we define 1 ampere? We have the formula 1 ampere is equal to 1 coulomb per 1 second. In the previous slide I have shown that 1 ampere is equal to 1 coulomb per 1 second. So based on this, that is from this formula, I is equal to Q by T. From this we have written this formula in terms of units. So we can define 1 ampere as the electric current through a conductor is said to be 1 ampere if 1 coulomb of charge flows through any cross section of the conductor in 1 second. That is, if there is a flow of charge of 1 coulomb in 1 second through any conductor, cross section of conductor means through its area of conductor in 1 second, then we call it as 1 ampere. Okay, this is how we define 1 ampere. So this definition also, definition of electric current as well as definition of 1 ampere also you need to understand. Okay, this is directly from this formula, and we have written this formula in terms of its units. Then we have directly defined from this formula. Okay, hope it is very clear. Now we have to define electric current in terms of number of electrons. Okay, the same formula, whatever we have studied now, we have rewrite it in terms of number of electrons. For that, let n be the number of electrons through any cross-section of the conductor in 1 second. There are huge number of electrons in a conductor. So let's suppose we consider that in 1 second, number of electrons flowing let be denoted by small letter n. Then total charge flowing through the conductor will be equal to n times E, because total number is n and charge of one electron is E. So it is denoted by E. Okay, that 1.6, that value is denoted by E. So we can write total charge Q is equal to n times E, where E is the charge on each electron. So we can write the formula, rewrite the formula of electric current I is equal to Q by T as Q we can replace using this formula, n into E. So you can write I is equal to Q divided by T is equal to n into E divided by T. Okay, just we have replaced Q with n into E. Clear? Then number of electrons constituting 1 coulomb of charge in 1 second. Then what is this n we can find out. Okay, we have to find out the number of electrons in 1 coulomb. How many electrons are there in a 1 coulomb of charge in 1 second. Okay. For that purpose, you do this same equation we are using, I is equal to Q by T, that is I is equal to n into E by T. From this we write n is equal to Q by E. Okay, here we have to substituted number of charge and number of electrons n is equal to Q by E, where Q, if Q is substituted as 1 coulomb, you can write it as 1 by E. Okay, just using this equation, and we are substituting Q is equal to 1 coulomb. So n we will get as 1 divided by E. What's the value of E? Just substitute the value of E, 1.6 into 10 raised to minus 19. Okay, its value is 1.6 into 10 raised to minus 19. It's reciprocal. So 1 divided by 1.6 into 10 raised to minus 19 is equal to n. That is the total number of electrons, and that value comes out to be 6.25 into 10 raised to 18. When you divide 1 divided by this value, you will get 6.25 into 10 raised to 18. So these many number of electrons are there per second in 1 coulomb of charge. Okay, this calculation, this value you need to remember. Okay. So that is all about electric current and its SI unit and total number of electrons in a 1 coulomb of charge. Now we will see another important term of this chapter, that is electric potential and potential difference. Okay, electric potential and potential difference. So in order to understand the concept of potential difference, let us consider flow of water in a tube. Okay, just a simple example, we are considering flow of water in a tube. If water in a perfectly horizontal tube, if you are considering water in a perfectly horizontal tube like this, if you are keeping a tube like this, water cannot flow. Simply water will not flow. There should be some arrangement for this water to flow. You might have seen at your home and everywhere some tank is kept at higher level, right? Tank will be kept at higher level and the tap will be at lower level. So water will flow from tank to water, like that the flow is processed. So like this, if you consider a simple case, this is the water tank. So water tank to pipe. So here one pipe is kept. Okay, this time roughly drawing. Okay, so now consider if one end of the tube, this is our tube. Okay, this our tube is connected to the tank of water. This is the tank of water. Okay, so this is tank of water. So one end is kept at the tank of water at higher level. This is at higher level, and the pipe is, see, tap is at lower level. Then what will happen? Now the water starts flowing from higher to lower level. This is because of the pressure difference. Okay, this is because of the pressure difference between the ends of the tube. So here and here there will be a pressure difference. So higher pressure to lower pressures, then water starts flowing. The same how we are the case of conductor. Okay, in a conductor, electrons move only when there is a difference in electric pressure. See, water flows when there is a pressure difference. Similar term we will use here, that is electric pressure. That electric pressure term is called potential difference across the conductor. Okay, very important term. That is, in order for the electrons to flow from one part of the conductor to another part, there should be a electric pressure difference, that is known as potential difference along the conductor. What is potential difference? So this potential difference may be produced by battery or consists of one or more cells. That is, usually you will see in any circuit, a simple circuit, if you consider, there will be cell or battery. So this battery will provide this electric potential difference. Okay. Now we'll understand in more detail how current flows in a conductor. Okay, how current flows in a conductor. Suppose if you are considering a conductor, when cell is connected across the end of this conductor or wire, metallic wire or conductor, a cell is connected at both the ends. So one end of the wire becomes, see, cell means cell notation, one end will be positive and other end will be negative. So the one end of the wire becomes positively charged and other end becomes negatively charged. Cell you might have seen at your home, battery will be there. Just see, one end is positive, other end is negative. So there will be chemical reaction inside the cell. Okay, this will produce as a potential difference across the terminal of the cell. Then this sets the charges in motion and produces an electric current. Okay, so this is read as this sets. Okay, this sets the charges in motion and produces an electric current. So basically, in order for the electric current to flow in a conductor, what is required? A potential difference is required. Very, very important point. Okay, very important concept. Potential difference is required. So in order to provide this potential difference, how it is provided? Using a cell or battery. It can be cell. Okay. Now we'll define the potential difference. So in every term we have to define in a systematic way. So we'll define electric potential difference. So potential difference is denoted by letter capital V. Okay, V is the notation used for potential difference. See, before that, let me ask you, are you familiar with the potential energy? In your class 9 you have studied about potential energy. What is potential energy? Just think about potential energy, because that term is familiar, right? Potential. So potential energy is the energy possessed by the body by virtue of its by its configuration or by its position, like that, or its shape. That's the potential energy. And we have defined potential energy is the work done, energy stored due to work done. So similarly, we have to define potential difference also in terms of work done. We use the term work done here. Okay, let us see how the definition is. Electric potential difference is coming. So there will be 2 points. Okay, electric potential difference between 2 points in a conductor is defined as the work done to move a unit charge from one point to another. It is denoted by using symbol V. Okay, so this is how electric potential difference is defined. Okay, so I said, if we connect a cell to a metallic wire, it will provide a potential difference. That potential difference is actually, how it is created is by doing a work. Who is doing a work? A unit charge. That is in the positive. The battery, there will be charges. Okay, free charge. This charge is doing a work. So work done to move a unit charge from one point to other. How much work is done? That is known as potential difference. Okay, it is denoted by symbol V. You need to remember this definition as well as formula also. Now we'll define the formula. Potential difference V between 2 points is equal to work done by charge. Okay, what is work done? It is denoted by W and charge is denoted by Q. So we are getting another formula here. That is the formula for potential difference, V equal to work done by charge. Very important formula. V is equal to W by Q. Okay. So now this is the third important formula. First we have studied about, we have seen what is charge Q. Then we have defined electric current, I is equal to Q by T. Now we are defining potential difference, that is V is equal to W divided by Q. Okay, remember this formula as well. Now SI unit. SI unit of potential difference is volt. Okay, see notation of its unit and its quantity. Both are V only. Okay, both we denote using V only. So potential difference SI unit is volt. That name came from a physicist named Alessandro Volta, an Italian physicist. So named after his name. Okay, Alessandro Volta. So accordingly, we named the potential difference SI unit as volt. Okay, volt. So formula for electric potential difference V is equal to W divided by Q. Okay, remember the formula first. Then its SI unit is volt. What was the formula for electric current? I is equal to Q by T. That was the unit for electric current, ampere. So here it is V equal to W by Q, and its unit is volt. Now we can write this in terms of this formula also. SI unit of work done is joule, right? SI unit of work done is joule and SI unit of charge is coulomb. Accordingly, we can define 1 volt. The same way we have defined 1 ampere, we are going to define 1 volt now. How do you define? Just think. First you have to use this formula. And left hand side you write 1 volt. Right hand side you write the unit of W as well as unit of Q. Then we define. Okay. Definition of 1 volt. Potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. This is how we define 1 volt as. Okay, once again, it is the potential difference between 2 points in a current carrying conductor when how much work is done? 1 joule of work is done to move 1 coulomb of charge from one point to another. This is how we define 1 volt. This directly what we got from that formula. This formula 1 volt is equal to 1 joule per coulomb. That is 1 volt is equal to 1 joule per coulomb. So from this formula we have written this definition. So this is another definition of another SI unit. So 2 SI units we have defined now, ampere as well as volt. Okay. Now one more in the heading you might have seen electric potential also. Same way only, electric similar to potential difference only. Electric potential means it is with respect to a particular point. Whereas electric potential difference is with respect to 2 points. Okay, potential difference between 2 points, whereas electric potential single point. So electric potential at a point, okay, particular point in a conductor is defined as the work done to move a unit positive charge from infinity to that point. Okay, it has same notation and same formula, everything is same as potential difference, only definition changes. Here work done to move from infinity to that point, whereas in potential difference work done to move from one point to another point. That is the only difference. Okay, otherwise it is same. Since a few important points about the topics we have already covered. See, with respect to electric current, we are using a instrument to measure electric current. It is known as ammeter. What is ammeter? So ammeter is an instrument to measure electric current. Its symbol is like this, ammeter. And another important point about ammeter is it is always connected in series in the circuit. What is series and what is parallel? All this you will understand in the coming videos. Similarly, voltmeter is an instrument to measure the potential difference. So two important terms we have defined is electric current as well as potential difference. In this electric current measurement is done by using ammeter. Potential difference is measured by using an instrument known as voltmeter. So ammeter and voltmeter, remember. And as ammeter is connected in series, voltmeter is always connected in parallel. Is that series and parallel, how this connection, all these you will understand later. Okay, no need to worry now. The symbol of voltmeter is like this, V. Ammeter symbol is using A, voltmeter using V. Okay, this positive and negative we will understand later. Now another important point about this discussion is cell is the simplest device to maintain potential difference. So to provide potential difference in any circuit, a cell is used. Okay, cell is the device to maintain potential difference. Another important point, current always flow from higher potential to lower potential. Okay, that means current is, direction of current flow is positive to negative, right? Positive to negative. That is opposite to the direction of electron. And the positive is considered to be the point of higher potential, negative is considered to be the point of lower potential. So positive to negative. Now next topic is electric circuit. Okay, electric circuit. So a continuous and closed path of an electric current is called electric circuit. Okay, electric circuit definition is like this. It is a continuous and closed path of electric current. It consists of source of electric energy, that means a cell or battery, and some other components and devices as well. Okay, in an electric circuit there will be some other components and devices along with the battery. Okay, we have two types of electric circuits, that is open circuit and closed circuit. What do you mean by open circuit? When it is open, that means when it is switched off, circuit is switched off, we call it as it is open. When there is no electric current flows in a circuit, it is open circuit. In closed circuit, where the electric current continuously flows in a circuit, then we call it as closed circuit. Okay, two types, open and closed. Open means there is no flow of current. Closed means there is a flow of current. So in terms of switch, when we talk, open circuit means it is switched off. Closed circuit is it is switched on. Okay. Typical circuit diagram of a simple circuit. It consists of a cell, a key, ammeter and bulb. Okay. So this is a typical circuit diagram. It consists of a cell. This is how a cell is denoted. Cell means one. This is actually battery, combination of two cells. Okay. Then a key, ammeter and bulb. Okay. These are the important components. So we will study how to represent these components in a circuit. So this is the simplest circuit. It has a cell. This is the notation for cell, key, ammeter and battery. Sorry, not battery, bulb. Okay, this is the bulb notation for bulb. Okay, in the next slide you will understand how we will represent all these. So some symbols used in components of a circuit. So cell is represented by using this symbol. So this is positive terminal of the cell. This is negative terminal of the cell. So you put positive and negative. So this is cell. The combination of the cell is called battery. If you are connecting more than one cell at a time, we call it as battery. There you have 1, 2. Here we have drawn 1, 2, 3. 3 cells. So at each cell, no need to put positive and negative. First one positive and at the end one negative. That would be enough. Key or switch. This is how a key is denoted. It is open key. That means there is no flow of current. Open circuit, key. Closed circuit, key. One dot is put in between. Okay, this means it is closed circuit. Current is flowing through the circuit. Wire. Two wires, if you are connecting, if they are joining two wires, this is how we connect. Two wires are there in a circuit which is not joined, then this is how we connect. Bulb, electric bulb, either by using this notation or a bulb itself you can draw. Next two terms you will understand later only. Okay, later of the session, part 2 of the chapter, you will understand what is resistance and rheostat. So resistance symbol is like this and rheostat symbol is like this. Okay, just understand now, time being. You will understand it later. This is the notation for ammeter and voltmeter. Okay, these are the important components. Some of the important components we commonly use in our electric circuit diagram. Okay, whenever you are asked to draw an electric circuit diagram with ammeter, voltmeter, key, bulb, you have to use these particular symbols. Okay. Few questions along with the answers. These are the questions given in your course book itself. Name a device that helps to maintain the potential difference across a conductor. Can you name it? What is the device which is used to helps to maintain potential difference? Answer is cell. Okay, cell. Second question is, what is mean by saying that potential difference between 2 points is 1 volt? There you have to define what is 1 volt. 1 volt we have defined now, 1 coulomb per 1 joule per second. That definition you have to write for 1 volt. Okay, joule per coulomb, that definition. Third one, how much energy is given to each coulomb of charge passing through a 6 volt battery? Energy or work done is asked. Each coulomb, charge is 1 coulomb. Potential is 6 volt. How do you find, which formula will you use here? So what are the given data? First you have to write, and what is asked, that also you have to write. Then you will understand which formula to be used. Okay, see here the answers. First one is cell. Second one, write the definition of 1 volt. Okay. Third one, you have to use this formula. V is equal to W by Q. And here W is asked. Energy is nothing but work done. That is asked. W is equal to Q into V. And it is given that Q is 1 coulomb. And volt, it is given potential is 6 volt. Just multiply 1 coulomb into 6 volt. Answer is 6. And the unit of work done is joule. So answer is 6 joule. Okay. Some homeworks. These are the example problems in your course book 12.1 and 12.2. Complete in your numerical notebook. Also answer these questions. Okay, what does an electric circuit mean? That is already given in my slides, so you have to answer this in your notebook. Define the unit of current. So what is the unit of current? 1 ampere. So you have to define ampere, not the current. Okay, you have to define unit of currents. That means you have to define what is 1 ampere. That definition is also given in my slide, so just write it in your notebook. Calculate the number of electrons constituting 1 coulomb of charge. That calculation also we have done also. Okay, so these are the homeworks for you. Okay, you have to write all the problems in your numerical notebook. I have told you, right, you have to maintain 2 notebooks. So numericals you write in a separate notebook. So these are the example questions. If you have not understood it, just ask me. Okay, so that's all for this part 1. Thank you very much, dears. Okay, learn well, and if you have any doubts, you ask me.